Hello students, welcome to Rayat Shikshan Samstha Satara, Rose project of 11th Science conducted by Yashwantrao Chavan, Institute of Science, Satara. We are studying topic number 6 from 11th Physics, Mechanical Properties of Solids. And in today's lecture, we are going to study these 2 points. First one, hardness, and second one, friction in solids. Let us see the first point, hardness. It is the property of a material which enables it to resist plastic deformations. Means it opposes the plastic deformation. Also, it is the property of a material which gives it the ability to resist permanent deformation when a load is applied to it. Hardness refers to stiffness or resistance to bending, scratching, abrasion, or cutting. Hard materials are little ductile in nature and they are brittle to some extent. Greater the hardness, greater is the resistance to deformation. Hardness is different from strength and toughness of a material. Example of hardest material is diamond, and that of low hardness is aluminum. So this is for hardness. Now let us see the next point, which is related to strength of a material. Strength means it is the higher is the force required for deformation, the stronger is the material. That is, the material has more strength. Steel has high strength, whereas plasticine clay is not strong. Now let us see what is meant by toughness. It is the ability of a material to resist fracturing when a force is applied to it. Plasticine K is relatively tough as it can be stretched and deformed due to applied force without breaking. So this is for toughness. A single material may possess more than one of the properties. Let us see these properties. For example, first one, bulletproof glass is hard and tough but not strong. Then second one, drill bits must be hard, strong and tough for their work. This figure represents different types of drill bits used in drill machine. या फिगर मध्ये ड्रिल मशीन मध्ये होल पाडण्यासाठी यूज केले जाणाऱ्या वेगवेगळ्या शेपचे ड्रिल बिट्स दाखवलेले आहेत आणि हे ड्रिल बिट्स ड्रिल मशीनला बसवून वेगवेगळ्या टाइपचे होल किंवा त्या शेपचे होल पाडले जातात. Then third one, anvils are very tough and strong, but they are not hard. This figure represents anvils. Anvil means it consists of a heavy iron block with a flat surface. So in this figure, this is a heavy iron block with a flat surface. And on that flat surface, metal is hammered and converted into a desired shape. Anvil म्हणजे मराठीतच आपण असे म्हणू शकतो, जी लोहाराकडे ऐरन असते ती anvil झाली. So this is all about hardness. Now Let us see the next point, which is friction in solids. Here, first we have to see the concept of frictional force. Whenever the surface of one body slides over the surface of other body, then each body exerts a certain amount of force on the other body. Let us consider this first figure. This is a horizontal surface, and on this horizontal surface, a wooden block is kept. When this wooden block slides on this surface in this direction due to the applied force, then during its sliding on this horizontal surface, surface of the wooden block exerts a force on the horizontal surface. And at the same time, horizontal surface also exerts a force on the surface of the block. Consider second figure. This is a horizontal surface, and on this horizontal surface, this object is placed, or it is kept on the horizontal surface. By applying a force, object is pulled to the left side. When this object will slide on this horizontal surface to the left, then surface of the object exerts a force on the horizontal surface. At the same time, horizontal surface also exerts a force on the surface of the object. Now consider third figure. Ball is rolling on the ground. Ball is rolling to the right direction. Then when ball is rolling, surface of the ball exerts a force on the ground surface. At the same time, ground surface also exerts a force on the surface of the ball. We see that here the forces exerted by these bodies on each other are tangential to the surfaces. That means they are parallel to the surfaces, and the force on each body is opposite to the direction of motion between two bodies. And these forces prevents or opposes the relative motion between two bodies. It is our common experience that an object placed on any surface doesn't move when a small force is applied on it. This is because a certain amount of opposing force is acting on that object, and that force is between surface of the object and the surface on which object is placed. To initiate any motion between pair of the surfaces, some minimum amount of forces required. And once the motion is initiated between the two surfaces, then that motion is constantly opposed by some natural force. And therefore here we define frictional force as the mechanical force between two solid surfaces in contact with each other is called as frictional force. And here friction is also defined as the property which resists the relative motion between two surfaces in contact is called as friction. Let us see one example of friction. First one, a rolling ball comes to a rest after covering a finite distance on the ground because of friction. Let us consider another example. Our footwear is provided with designs at the bottom of the sole. So they are provided with a design at the bottom of its sole so as to produce force of friction to avoid slipping. Third one example, relative motion between solids and fluids is also opposed naturally by the friction. For example, boat on the surface of water experience opposition to its motion. So this is about some examples of friction. Now, let us see the next point, which is origin of friction. Let us consider this figure and another one, this figure. Here we have to see what are the causes of friction. Generally, when we observe any smooth surface under a high power microscope, then we find that that smooth surface consists of hills and dales. म्हणजेच त्या सरफेस वरती चढ आणि उतार असतात. फॉर एक्झाम्पल, या फिगर मध्ये हे दोन सरफेस दाखवलेले आहेत. हा एक सरफेस आहे आणि हा एक दुसरा सरफेस आहे. या पहिल्या सरफेस वरती हे डेल्स आहे, म्हणजे हा उतार आहे आणि हा चढ आहे. सो दिस सच अ सरफेसेस, smooth surfaces, when observed under high power microscope, then it is found that they consist of minute hills and dales. Hills and dales are also termed as elevations and depressions. And these hills and dales or elevations and depressions are termed as irregularities of the surfaces. Irregularities of the surfaces. So when two surfaces having irregularities, for example, in this figure, this is the first figure and this is the second one. Sorry, this is when two surfaces having irregularities. So consider this is the first surface. It have some irregularities, means hills and dales, and this is the second surface which also have hills and dales, means some irregularities. When two surfaces having irregularities, they have a relative motion between them. Then hills on one side get interlocked with dales on other side, and dales on one side get locked with hills on other side. And this is called as interlocking of irregularities. And therefore, first cause of friction, or one of the cause of the friction, is the interlocking of irregularities, means elevations and depressions or hills and dales between two surfaces in contact when they have a relative motion, is one of the cause of friction. Now, let us observe this figure. In this figure, this is one surface, this is another surface. We see that both these surfaces contain minute hills and dales, means they have irregularities. We see that their apparent area of contact, area shown by dotted blue line. In this first figure, this is the apparent area for these two surfaces in contact, shown by dotted line. And for this second surface, which consists of hills and dales, two surfaces, we see that the area shown by dotted blue line, this is the apparent area of contact of these two surfaces, is very large. And if we consider their real contact area, means where these two surfaces touch with each other, for example, here, 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 shown by green arrows, we see that real contact area of these two surfaces is very small. As area is here very small, then pressure at the point of contact increases. So at this point of contact, at this point of contact, pressure increases, and hence there is a strong force of attraction between the surfaces. There is a strong force of attraction between the surfaces according to modern theory. So second reason or second cause of the friction is, according to modern theory, force of attraction between molecules of two surfaces in actual contact is second cause of the friction. Now, if these two surfaces are made smooth by polishing them, then their actual area of contact increases. As they are made smooth by polishing them, here force of friction increases. It doesn't decreases, but force of friction increases. And therefore, here the forces which are responsible for maximum force of friction or friction are, there are two types of the forces: cohesive force and adhesive force. So here let us see what is meant by cohesive force and adhesive force. So cohesive force means when two surfaces are of same material, the force of attraction between them is called as cohesive force. And second one, adhesive force means when two surfaces are of different materials, the force of attraction between them is called as adhesive force. So this is all about origin of friction. Now, let us see the next point, which is types of friction. There are three types of friction. First one, static friction. Second one, sliding friction or kinetic friction. And third one, rolling friction. Let us first see about static friction. Here, first we have to see the concept of frictional force. Let us see this figure. In this figure, this is a horizontal surface. And on this horizontal surface, a wooden block is kept. On this wooden block, a force F is applied. But due to this applied force F, wooden block doesn't move. This is because this applied force doesn't overcome the force of friction between surface of wooden block and that of horizontal surface. Then here, force of static friction is defined as the frictional force which balances applied force when the body is static is called as force of static friction. In other words, static friction prevents sliding motion. Here, if we go on increasing the applied force F on the wooden block, then there arises some few cases. Let us see these cases one by one. The first one, if we keep increasing F, means applied force on the wooden block, then the stage will come such that applied force F is less than maximum force, then the force of static friction is equal to applied force F. Next one, when the applied force F is equal to maximum force, then the object will start moving. Then means for this condition, this block will start moving on this horizontal surface. Third one, if applied force F is greater than equal to maximum force, then kinetic friction comes into play. That means this block will slide on this horizontal surface. Static friction opposes impeding motion, that is, the motion that would take place in absence of frictional force under the applied force. Let us see what is meant by limiting force of friction. Just before the body starts sliding over another body, the value of frictional force is maximum. Then such a force is called as limiting force of friction. Force of static friction is a self-adjusting force. This is because force of static friction adjusts itself in according to applied force. Therefore, force of static friction is called as self-adjusting force. So, this is all about concept of static friction. Now, let us see the laws of static friction. We know that static friction means friction between two bodies in contact when one body just tends to move on the surface of other body, then it is called as static friction. Let us see the laws of static friction one by one. The first law, the limiting force of static friction is directly proportional to normal reaction N between the two surfaces in contact. If here FL be the limiting force of static friction and N be the normal reaction, then as per statement of the law, we can write FL directly proportional to N. Rearranging this equation, we get limiting force of static friction is equal to mu s into N, where mu s is the constant of proportionality and it is called as coefficient of static friction. Rearranging this equation for coefficient of static friction, we get mu s is equal to FL upon N. And from this equation, we can define coefficient of static friction as it is the ratio of limiting force of static friction to the normal reaction. Second law, limiting force of static friction is independent of the apparent area between the surfaces in contact so long as the normal reaction remains same. Third law, limiting force of friction depends upon materials in contact and the nature of their surfaces. So this is all about laws of static friction. Now, let us see second type of friction, kinetic friction. Kinetic friction means friction between two surfaces in contact when one body is actually sliding over the other body is called kinetic friction or dynamic friction. Let us see the laws of kinetic friction. The first law, the force of kinetic friction, Fk, is directly proportional to normal reaction N between two surfaces in contact. So as per this statement, we can write in the form of equation as Fk is directly proportional to N, and therefore Fk is equal to mu k into N, where mu k is constant of proportionality and it is called as coefficient of kinetic friction. Rearranging this equation for mu k, we get mu k is equal to Fk upon N. And here we can define coefficient of kinetic friction as it is the ratio of force of kinetic friction to the normal reaction. Second law, force of kinetic friction is independent of shape and apparent area of the surfaces in contact. Then third law, force of kinetic friction depends upon the nature and material of the surfaces in contact. And fourth law is the magnitude of force of kinetic friction is independent of the relative velocity between the object and the surface, provided that relative velocity is neither too large nor too small. So this is all about laws of kinetic friction. Now let us see the third type of friction, which is rolling friction. Rolling friction means friction between two bodies in contact. When one body is rolling over the other is called as rolling friction. For example, ball rolling on the ground surface. Now, let us see some advantages of friction. First advantage, walking. We are able to walk because of friction between our feet and ground surface. Holding of an object in an hand is because of friction. Brakes of vehicles work due to friction, and that's why vehicle stops. So these are the some few advantages of friction. Then let us see what are the disadvantages of friction. First one, it opposes the motion. Second, friction produces heat in different parts of machine and also noise. Automobile engines consumes more fuel due to friction. So these are the some disadvantages of friction. Now, let us see some methods of reducing friction. First one, use of lubricants, oils, and grease in different parts of a machine reduces the friction. Use of ball bearings convert kinetic friction into rolling friction. So these are the few methods for reducing friction. And here is the end of the topic, mechanical properties of solids. Thank you.